This lecture is on learning how to write the cell notation of spontaneous redox reactions. Cell notation is an alternative form where one describes a spontaneous process for a galvanic cell reaction. Let's look at the symbols used for cell notation. A double bar or two vertical lines parallel means salt bridge, where a separation between the anode and cathode half cells are noted. A single bar or one vertical line means a phase barrier between the electrode and species in the same half cell. A comma is common used between two components, usually within the same half cell. An S in parentheses means the substance was a solid in the system. A L in parentheses means the substance was a liquid in the system. A G in parentheses means the substance was a gas in the system. And a Q in parentheses means the substance was in aqueous solution in the system. The general format for cell notation is electrode, vertical line, species, double vertical line, species, vertical line, electrode. The anode half cell is written on the left side and the cathode half cell is written on the right side, separated by the salt bridge. Electrons flow from anode to cathode. Let's look at a few examples, all of which are spontaneous processes where the cell potential is greater than zero. The first example is solid copper reacting with 2 moles of aqueous silver plus to form aqueous copper 2 plus and 2 moles of solid silver. The anode half reaction is in the left half cell, and the right half cell contains the cathode half reaction. The cathode has the reduction of aqueous silver plus ions, forming solid silver, and the anode has the oxidation of solid copper, forming aqueous copper 2 plus ions. The cell notation for this process is solid copper, vertical line aqueous copper 2 plus ion, double vertical line aqueous silver plus ion, vertical line solid silver. The second example is hydrogen gas plus copper 2 plus, forming 2 hydrogen ions, and solid copper. The cathode half reaction is in the right half cell, and the left half cell contains the anode half reaction. The cathode has the reduction of copper 2 plus, forming solid copper, and the anode has the oxidation of hydrogen gas, forming hydrogen plus ions. The cell notation for this process is solid platinum, single bar, hydrogen gas, single bar, hydrogen ion, double bar, copper 2 plus, ion, single bar, solid copper. An inert electrode is used for half cells where it doesn't react with the components. Some other examples include carbon and palladium, both solid state. The third example is hydrogen gas plus 2 silver plus, forming 2 hydrogen ions and solid silver. The cathode half reaction is in the right half cell, and the left half cell contains the anode half reaction. The cathode has the reduction of aqueous silver plus, forming solid silver, and the anode has the oxidation of hydrogen gas, forming aqueous hydrogen plus ions. The cell notation is solid platinum, single bar hydrogen gas, single bar hydrogen ion, double bar silver plus ion, single bar solid silver. The fourth example is solid zinc with 2 hydrogen ions forming hydrogen gas and zinc 2 plus ions. The cathode half reaction is in the right half cell, and the left half cell contains the anode half reaction. The cathode has the reduction of aqueous hydrogen plus ions forming hydrogen gas, and the anode has the oxidation of solid zinc, forming zinc 2+. The cell notation for this process is solid zinc, single bar, zinc 2+, double bar, hydrogen ion, single bar, hydrogen gas, single bar, solid platinum. The last example is 3 moles of solid magnesium with 6 moles of aqueous iron 3+, forming 6 moles of aqueous iron 2+, and 3 moles of magnesium 2+. The cathode half fraction is in the right half cell, and the left half cell contains the anode half fraction. The cathode has the reduction of aqueous iron 3+, forming iron 2+, and the anode has the oxidation of solid magnesium, forming aqueous magnesium 2+. The cell notation for this process is solid magnesium, single bar, aqueous magnesium 2+ ion, double bar, aqueous iron 3+, comma, iron 2+, single bar, solid platinum. Here is a review exercise for you to work on. Write the cell notation for this system. The left cell is the oxidation of magnesium, and the right cell is the reduction of hydrogen ion with Pt as an inert electrode. For the remaining part of this lecture are solutions to review exercises or problems. Please view only after completing these exercises.